Alright, so welcome to another video on the MyPlasm CNC Systems 1.0.7a. We're going to, of course, do updates. Let's move on to the cutting parameters. So when we go to cut a part, we're going to need to make sure that we're cutting the part at the right speed relative to the thickness of the material, relative to the amperage of our plasma cutter. There are a number of factors here. For the sake of this video, we're going to be using the Hypertherm 45 XP as the standard. We're going to be using that manual in order to build out the speed settings that we're going to use to then cut with the table. So let's go ahead and get right in with this. So we have a number of different options for tooling. Here we have cut speed 2, cutting height THC, pierce height, pierce time, and floating height. Let's go over these one by one and get some definitions rolling here. So first one's cutting speed. This is just going to be your run-of-the-mill cutting speed. This is for anything that involves any normal cut, not a small detail, not things like bolt holes or what have you. The cutting speed is just going to be your cutting speed as defined by your plasma cutting book. So that's that. Cutting speed 2 is your slow cut speed. So this is for small details. This is going to be for corners. This is going to be for specifically moments where the torch is going to be moving through areas that it needs to slow down for, like corners, like circles. And it's also where the THC is going to be turned off in order to keep the torch from let's say diving into the material, because as you go slower your THC voltage changes, and we can dive into THC a little bit later. But just understand that this cutting speed 2 allows the system to maintain the appropriate cut height around corners and smaller features. And speaking of appropriate cut height, we have the cut height here, which is set at 0.06 inches, which is in what the actual Hypertherm cutting book tells us. So we're going to keep that at 0.06. Our cutting height based off of the THC, that's a voltage. That voltage is also in your Hypertherm manual or your Hypertherm handbook there. Now our pierce height is a little bit low. According to Hypertherm, we're going to keep this at 0.15, which is in the book here. We'll open that up, and I'm just going to go ahead and hit enter there. And then our pierce time is going to be milliseconds, 500 milliseconds. That's going to change based off of our material. And then our floating height. Floating height is going to be the height at which the torch moves up in between cuts. This is what the Mach 3 manual calls the rapid clearance, but for the sake of MyPlasm, they call it floating height. So torch is going to make the cut, lift up to 3/4 of an inch off the material, move to the next cut location, and come down, touch the material, and start cutting again. So that's going to be your floating height. That's your rapid clearance. That's your safety clearance, whatever you want to call it. It's that feature. So let's go ahead and get this set up for a Hypertherm 45 XP at 16 gauge using 16 gauge mild steel using standard consumables. And I'm going to go ahead and open up the manual here for the Hypertherm. This is the 45 amp. I'm using this consumable set here. That's the 22091. I'm not using fine cuts in this case. If you want to use fine cuts, you can set up those parameters as well. So let's go ahead and go in here. 16 gauge. We have a torch to work distance. So this is our cut height. That's 0.06. Pierce height is 0.15. Beautiful. All right. My pierce delay is going to be 0.1. So that's going to be 100 milliseconds. We'll go with that. Our best cut speed is going to be 249 inches a minute and 128 volts. And my kerf width is going to be 0.053. We'll keep that in mind when we go to work on our parts later on in another video. However, for the sake of getting our cut settings correct, we have a pierce delay of 0.1, cut speed 249, and this is going to be for our 16 gauge, so 128 volts. Let's go back to MyPlasm. We're going to make those adjustments here. 128 is going to be my voltage here. Again, this isn't going to be, let's call it, this isn't the end-all be-all of voltages. As your torch is being used, as you have more liquid in your line, as the consumables begin to wear out, as particulates develop in your line, That voltage is going to change over time, so don't take this as you have to follow whatever the book says. There are a lot of settings that are fine-tuned and adjusted off of whatever the book says. The book just gives you a great starting point. We're going to keep that at 128. My cutting height was right at 0.06. My pierce height was right at 0.15. My pierce time is a little long. We're just going to go with 100 milliseconds there. Great. I'm going to keep my floating height there. That's just a personal thing. If you feel like bringing it up higher or lower, be my guest. You don't have to keep it at 0.75. 9 times out of 10 with a lot of customers, we just keep it that way. You can change that if you want. If you know your part, if you know you're not going to get many tip-ups, you can drop that lower and lower, and that will just continue to increase the speed at which you're cutting. So it's up to you. All right, so my cutting speed, my major cutting speed is going to be 249. And for my holes, now, I don't have a specific formula for this. I just go off of my gut. Typically, when I'm cutting holes into thinner material like 16 gauge, I can keep it at 249 if I want to. For the sake of this, I'm just going to actually drop it down to 200 inches a minute because I can get a little more clarity from particularly holes. Holes tend to cause some issues with the way that the plasma blade is shaped. It can cause some problems cutting circles. So slowing down typically helps with those, and so I'm setting that at 200. And that is how we get our cut speed set. But let's say we want to save this. I'm going to go ahead and actually type in. Let's go ahead and type in what this is. Oh, I used to be able to type. So 45A, 16G, mild steel. And we're going to go with standards. Now, once we have that, I can just hit Control S. And that's saved down here. Perfect. So now I can go back and make another tool set. So let's go ahead and make another tool set while I'm here. And you can actually see, oh, they show you right here. Save, Control S, delete, Control D. Well, let's go ahead and make another tool set here while we're here. I'm going to go ahead and go with, let's go with some 10 gauge here. Pierce delay of 400 milliseconds and 129 inches a minute. Strangely enough, 128 volts. So I'm just going to change that to 129 inches a minute and 400 milliseconds and make that 10 gauge. So let's go here and you know what? Things happen in my brain. There we go, 129. All right, 129 inches per minute. Quarter-inch holes are notoriously, let's say, fun to do. I'm sorry, 10 gauge holes are also fun to do. We want to make sure that we're not going to get an excessive curve there. I'm going to start off at 100 inches a minute, and if I want to change that later, I will. All right, so we got this. We have 128 volts because it's still the same. 0.15 inches off the material. That's correct piercing time. That was 400 milliseconds there, and then that's good. And then I'm just going to change this to 10G and hit Control Save. And now I have my 10 gauge and my 16 gauge set. So every time that I add a new tool set, it will store in this handy dandy little drop down screen here. So if you need to access more tools or need to build specific tools for what you're doing, I typically recommend just building them yourself. Will we have tools available for you to just download and use? Absolutely. But it uses a wide variety, or gives you an option for a wide variety of material. And more often than not, we see a lot of people just use 3 or 4 different thickness of materials all the time, and it would be a pain to have to dig through all of those tools all the time. So personally, I would just build the tool set based off of what you need for your situation, and then make small adjustments and continue to save them. And if you do make small adjustments to your tool, don't forget to hit Control S in order to save them, so that next time you go to cut that material, it's still retained there and you can use that in the future. So there we go. We have our tool sets all set there. We're going to just keep working with the 16 gauge mild steel for the time being, and we'll use that in our next video, which is going to talk about bringing in a part and how to make that happen. And there we go.